live. So, let's see. Do you have the source running or the feed running? Ooh, I can sign into my own feed. Nice. We have 2 people. So what are our topics? We have, what's it? View range first, I believe, and then it was view filters. Was it filters? Filters, and then view template. All right. That we are live. So let me see real quick. I'm assuming we can hear each other. Tom, say something. Tom, say something. This is not working well. Yeah, it's not. This is not working well. Audio output capture. Yeah, it's not. Let's see, speakers and headphones. Okay. Now maybe try say something. I think if I turn off mine, it looks better. Maybe. Oh boy. Well, I mean, here, you say, as long as your audio comes through, it should be good, but I don't hear any of your audio, Tom. Yeah, host, no, I don't see any, your audio's not going through to the live stream at all. All right, we might have to try a different platform. Yeah, let me try this. If we can get this to work, yes, we'll try to save this. Please bear with me. I haven't tried to like capture another guest's audio before, so I can get my own, but I can't get Tom's input on this. And that was kind of the point. Tom and I would be having a discussion about these topics, and we would try to shed some information. I thought if you connect mic and aux, it would try to capture this, but nope, that doesn't go either. Media source, nope, that's not it. Okay. I can hear you on this call, but I don't think we can hear, no one else can hear you. I'm pretty sure. That's slightly annoying. Yeah, I can get my audio through. That's slightly annoying. Okay. Well, we might have to do this, or I might have to go solo. Yeah, we'll have to work on this another time. Should have put more time ahead of this to figure this out. We might have to do this, or I might have to go solo. Yeah, we'll have to work on this. All right. We'll have you on next time, Tom. Thanks for trying. Yeah, a day before. But I'll go over some of these things today anyways. I'll answer some questions, and then we'll make the next one a little more interesting. All right, well, thanks, Tom. We'll drop off, and we'll get you next time. See ya. Thanks. Okay. Let me see if I can get my own camera back now. Thanks, Tom. I'll drop off, and we'll get you next time. See ya. Thanks. All right, well, that went about as smooth as nails. Next time we'll try to get, oh, let me turn this one off. I was trying to hear him. All right, so thanks for whoever's watching this, and hopefully this will be still useful. We had a couple topics that we wanted to go over, plus any live questions that come up. So let's see if we can get started. The three topics we wanted to kind of briefly talk was view range, filters, and view templates. If you guys have any other questions in mind, go ahead and bring them up. We did have a question from Patreon for Jose or Jesus, sorry. And he had a problem where his panel schedule balancing was not working. And the problem would be like he would try to balance this panel and it would just throw circuits completely like off the list. So hold on 1 second. Let me try to stop the monitoring. I'm like hearing myself 3 times. There we go. So yeah, he would try to balance this panel schedule. You see how over here it's quite off balance. We have phase B, it's pretty high amperage, and then the rest of it is pretty low. So hold on 1 second. Turn off Bluetooth. There we go. Okay, so over here you hit rebalance load, and normally it would try to rebalance this so that it's equal. Let's see what happens in 2023. Okay, so this won't rebalance just because I think these are all active loads. One of my theories was that your panel schedule would have, say, like 42 poles, and then for some reason your panel itself would be 84 poles. So if your schedule doesn't match up with your panel's total number of poles, it actually will throw some of this stuff down like below, and it'll run off of the page. So my guess is that you should try to find your panel first and figure out like if the panel itself has the same pole count as your schedule. Beyond that, I honestly haven't really had many issues with circuits falling off of the schedule. You could try to edit this. So if we try to open this up, under is it manage? You have panel schedule templates, edit a template. And over here, so here it is. So make sure like you have enough poles to sustain all your panel circuits. Sometimes it'll not be enough, and sometimes it'll be too much. So over here, number of poles, see constant value of 42. It should be based on the max number of single bolt breakers. So that way your panel and your schedule have the same. Beyond that, I'd have to almost sit down with you one-on-one to figure out what the problem is. Okay. All right. So we're gonna exit out of here real quick and get back to some of our topics that we had in mind. Here, let me see what we have. How to change family entity. What do you mean by family? Yeah, actually, that's a good question. I have a feeling that the question means like, let's say your lighting fixture, you want to change it to say something else. Instead of lighting fixture, you want to change it to, I don't know, lighting device, like this. So you would change that over, nope, not here. Right here, I think. Yeah, like make this a lighting device. That's kind of my guess. Which I think you would change it up here. Family categories and parameters. So if you want to call this this family a device, you can click on that, hit OK, and it'll change it there. That way it groups under the right category, and then if you were to be in your project and you want to hide a certain category, you can go over here and turn off your devices or fixtures correctly. So if you turn off devices, it actually will hide this fixture. Oh, I never loaded it. So if I load it back in, so I changed this light fixture to lighting devices. So load in and close. Overwrite. And this should get rid of it. There we go. Yeah. So now that fixture is now a device. So you can change it like that just by editing in your family categories and types. So hopefully that's the right answer for you. I know it's like sometimes it would be like a generic model and you want to like specialty equipment or vice versa. That you can go in there and change it that way. All right. So let's see. Oh yeah, we want to talk about view ranges. So view range is something that a lot of people get confused on. I would love for Tom to kind of talk this with me. Last idea, Tom. This might sound absolutely horrible. You know what? We'll try. We'll talk about it next time. I'll drive this boat for now. I was gonna call Tom and then we would just talk, you know, via the iPad, and his audio should be captured, but it might sound like crap. So, all right, we're gonna talk about view ranges quick. He sent over a very nice link. Let's see, where can I find it? From this morning, I guess. Here it is. All right, this explains some view ranges, and we can use this to go through a couple of these things. All right, so view range is something that helps you get your view that you want in your floor plan. And there's a couple parameters in here that dictate like what shows up on here. So where your bottom cut is, where your top is, and then where your cut plane. It shows different types of equipment. So some things don't show up, some things that can't be cut is actually the only things that can be cut, as far as I'm concerned, is walls, doors, windows, and something else here. Interacted by the cut plane, right? There's a couple things that can be cut. Not everything can be shown on the floor plane as a cut. And if it's not one of these categories, it will simply just not be shown or be projected using a dashed line. So we're gonna post this link in the live stream so that you guys can read it at your own leisure. But we're just gonna go through and start playing around with some of these, the bottom, the top, and the cut plane. And I'll show you how we typically set these up. So over here in this sample project, the view range is accessed in your properties window. And a lot of the time when you open it, you want to go off of levels. So like your project should have a couple levels pre-established that lines up with like your floor plan. So come on. Oh, I hate how the section cuts all the way through the building. I still have to fix that. Let's see. We'll just close this off a little bit. Go to view. And hey, why are my levels not showing? Yeah, that's kind of annoying. This view cuts off the levels. Let's see, crop. Oh, well, there should be levels here. So each floor should have a level. It's like, you know, this is level 1, this is level 2, and this is level 3. Let's try this. Yeah, I'm not sure why the levels aren't showing up, but they are there because obviously when you go over here to the view range, you can see it says level 1, and then level 2, and level 3. So when you set this up, you generally want to look for the bottom plane and the top plane to be where your floor is. So I set it at floor level for bottom, and then oh, this is all screwed up. 7/6 offset. Oh, because this is a ceiling RCP. So bad example. Let me go over here to, they have a power plan, right? Here it is. Main electrical room. There we go. View range. Holy moly. This is all messed up. All right. You would think that a sample project would be nicely organized. So you would have level 1 at 0. Your cut plane would generally be about like 3 to 4 feet so that it cuts through tables, doors, windows, and anything that you need to define a room. So put this at 4 feet. And then the top, you could do it one of two ways. You can do level and then have a designated height above the ground. So if you don't want to go all the way to the next floor, you can do that. But the other way to do it is to go to the next floor and offset 0. So that way it captures from floor to floor and everything in between. The last parameter down here is your view depth. So view depth, as far as I remember, is when you want to look below the bottom of your clip. So like if you're on first floor and you want to show like underground conduits, you can do something like 3 feet. And in this case, it kind of shows it. No, this is it. So it should show conduits that are below ground with a line weight of the line type beyond. So you can get a pretty good setup like this, and then if you need to tweak this, so for example, like if you had your cut plane up too high, you won't see the door. What's the actually it kind of does show that. So you see that the wall goes right through, it doesn't like end at the door. That's when your cut plane's not quite right. So if you cut this at the right area, you'll see that the door actually shows an opening. Would be nice to do like a 3D view here. So, I like how we're cutting 2 floors here. So which floor am I on here? So this is floor 1. So we're gonna just chop this down to floor 1. There we go. So I'm gonna try to graphically show you what it looks like when you cut at, say, 4 feet. If we do this and detail line, can I draw on here? Because that would be nice. Of course I can. So if you're cutting at, say, like 4 feet, you're cutting about midway through the door. So that's your cut plane. So everything from here on down, you'll see on your floor plan. Sometimes you'll have to cut it higher up if some of your equipment or things are located up on the wall here. I should probably check this. If light or equipment family does not work, how to fix it? Oh, okay. Your wattage is probably not being read off of your family correctly. Okay, all right, maybe we'll dive into that next. You know what? If you're annotating devices for a new project, do you use generic labels or do you use a device family and add a generic? You know what? I might table this. Okay, I'm actually getting questions this time. So last time I did this, I didn't have that many questions. So that's why I kind of had a plan to run through, and if I questions, I'll answer it. So, maybe I'll table this view range discussion when I can get Tom in on this as well, because it's more interesting when we have more than one person discussing this. So, all right, you know what? I'll drop this. I'll start answering some of these questions. So if light or equipment family wattage does not work, how do you fix it? All right. So your wattage and your loads have to be connected to your equipment connector. So how do I find that? Let's go to a floor plan. Let's grab a light. Okay, so power plan. Man, these things aren't very well set up for a sample project. I might stop using this. Okay, let's try to pull up a family for example. All right, so here is a fixture that has an electrical property. So you know that because you have the electrical circuit thing up here. So let's just copy this. Here, we'll detach this so I can show you what is going on here. Excuse me. There we go. All right, so here's a fixture that you can circuit. And in order to circuit this, you need an electrical connector inside the family. That electrical connector should be reading something like apparent load. This one might actually have a wattage as well. Okay, good. So you want to put in your load in like a text field like this, and it holds the value and then it sends it to your electrical connector. So if you were to open this up, let's show you where the electrical connector is in the family. All right, so you'll see the electrical connector as this like green circular thing with like a cross through it. So if you click on it, you'll see that it says connector element 1. And you can actually place, I think you can place a couple of these by, here it is, electrical connector. So if you need to add one to a fixture, you can do this and then you can select a spot and then it'll drop one of these connectors on here. And this is actually what you connect in Revit when you electrically circuit something. Your wires typically attach to this, so this is what holds the electrical properties of a fixture. So in order to get your load to this connector, you have to make sure that this over here, you see the apparent load phase 1, you have to make sure that this has an equal sign and that it is linked to the field that you're putting in your load. So let's say, for example, you had something different. We'll say like wattage for your example. You can do by type or by instance. If every single one of your fixtures has the same load, which typically is the case, you could do by type. But if you're doing like a junction box or a disconnect switch or something that is, instance based, then you would make this instance. So I'll just leave it at type. And then under parameter, you'll group it under electrical loads. Let's hit OK. And then, okay, so we'll hit it. We'll give the fixture a wattage instead. So if you hit OK, you can see that this now will read anything that wattage passes along to this electrical connector. So go ahead and make sure that that is linked, and then you load this into your project. Actually, I don't really need to save this right now. There we go. Load this into your project, hit no, overwrite, and then you should be able to grab your electrical connector with power pulling from the wattage. So you see here, yeah, see, I have wattage and apparent load as two separate things now. So if I were to circuit this, let's power this up. So I'll hit power. Let's just find a panel. Sure, lighting panel. That works. And you know that it is powered up with the correct load because you'll see, so if I zoom in a little bit, maybe like here, excuse me. I'm trying to do an example here. So if you click on a fixture and you have voltage here, you'll see like 64 VA. That's pulling in a load from the wattage field and then passing that on to the electrical connector, which then circuits it back to the panel. So that's how you know that the load is actually working. If I were to go in here and change this, let's say, 150. You know what? Let's make it something different. 200. Hit OK. It should update. There we go. See, now it's 200. What panel did this go to? This went to, it's got to be just the circuit. Lovely. None of these tags are here. Okay, so let's see which panel it went to. It should be LP1, right? Yeah, so if I pull up LP1, circuit 1. Any day now. There it is. Now you see the load being passed on. So just make sure that your electrical connector is linked to wherever your load is being input from. Okay, so hopefully that answers that. What's the next one? Sliced. When you're annotating devices for a new project, do you use generic labels only, or do you use a device family and add a generic label to the family to annotate at floor plan view? Okay, let me try to comprehend that. When you are annotating devices for a new project, do you use a generic label, or do you use a device family and add a generic label to the family? So if you were to generic label, starting a new project. Okay, I think I understand what you're trying to say. So for example, like a, I don't know, new air handler, right? To show the symbol of the device. Show the symbol of the device. I mean, yeah, but like if you're trying to put it like a receptacle on there, or data outlet, or are you talking about like equipment? Like sometimes if I get, I don't know, a random air handler. Do you add just a generic label for receptacles? Yeah, I think I do. Generically, I've just put, well, actually, I would always put the symbol. I hate this project. I need to stop using the sample project. So yes, I would put the family in there, and then I would use the family tag to annotate it further. So I would use the comment section. So like every fixture usually has like a comment thing. So I would put a generic family type, host it, and the symbol would show up. And then if you want to tag it, I would use a generic tag that pulls from the comment box. So you can describe it as like, GFI receptacle, or sometimes in this case, if we're lighting, you would put a generic lighting in there, and then you can comment type F1, and then from there just say a generic suspended industrial linear. Do you load a receptacle family and add the generic inside the family, so later then you start 3D model and you can connect the wires? Yeah, essentially you would do that. Add the generic label inside the family. Yeah, I try not to do any design just annotatively. Like, don't draw lines to show stuff like that. Like if you know you need a receptacle, put the receptacle in. It's honestly faster in a way. Yeah, and then as you work, you can always add more detail to it. Add your loads if you want to. You can add, extra equipment tags. You can actually house that in the family, and it's nice because then, like, if it moves around or if you make another view, all that information is stored in the family itself. Let me just make this my big screen. Yeah, so like if you were to just annotate something, then it becomes harder to like keep track of it later. The only time that you might actually do like a general annotation is like if it's not your stuff. Like sometimes the mechanical guys would just throw random air handlers, not give you a tag or anything. So that's when sometimes I might attach a generic tag to just like the equipment itself and then try to assign like a value to it. It's really hard dealing with that. And sometimes it's just like you put a text box on the floor plan. It gets that rudimentary because you don't have the permission to write to a mechanical equipment if it's like in a separate model or something. Um, if you guys are all working in like the same model, I know like some smaller MEP firms, they don't break out MEP separately into different models. It's all just one model. So then sometimes you could add information to their element, but I generally try to avoid touching anyone else's stuff because sometimes they'll use that field for something else and they'll just be like, hey, what's this information here? And they'll clear it out. Yeah, and so that's why sometimes just having separate models linked together is nice because then you can link in their stuff, type some text over it, and then you could just hide in view if that's easier for you to find out later. Okay. All right. Well, I'm glad that kind of helps you. Thank you. Let's see. I think I skipped a couple questions up here. If you're running annotation device, oh, there we go. Okay. How do underground view range for underground conduit run? All right. Yeah. So I kind of want to save that question for better elaboration. Maybe I'll try to do a Q&A with Tom like next week. I won't wait 2 weeks. So we'll try to set it up for maybe next Friday. I really like the interaction of being able to talk to someone and be able to like work something out. But to answer your question about how to view underground stuff. So like I said, it's the here, let me switch this over here. Let's go back to like a floor plan and view range. So it's this down here, your view depth. You want to make sure it's set to something that you can see. I think it's, there it is. So it's supposed to be, what's my cut plane? Can I do, is it 3 feet? Sometimes I forget, is it positive or negative? Okay, maybe it's positive. Nope, it's supposed to be negative. Okay, so I would do like level below. Let's just hit OK for now. So you see how, is this a 3D view? No, it's not. But this is actually an underground piece of conduit. So let's go over here to 3D. I'll try to show you if I can grab this, drag it down and drag it out over here. Let's do like fine or something. Okay, so you see how this is underground of this level here. So in order for you to see something down here, you have to make sure that your view depth is going to the floor below it. So yeah, you could do level below, or you can also do level 1 and do like an offset of I don't know how far it is. Okay, so I guess 8 feet works. I don't really know how far below it is, but you basically have to make sure that your view depth is under your conduits. Then it'll grab that and show that. It's actually supposed to show this as like a dashed line. I think maybe I have this. Yeah, I might have them graphics weird here. Hidden line? Or maybe this project doesn't have its line type. Oh, it is solid. Okay, let's try. Let's do, I don't know, center. Anything that, oh wait, it does show it. Okay, so yeah, so this line probably is just not done right. Come on, view scale. Okay, my view scale's off. I'm trying to show my point here, so I'm determined to get it to show up right. There we go, got it. Okay, so anything that is below your bottom clip, so whatever is in your view depth will be shown in this line type or line style. So it's beyond, and yeah, I just made it center. I think there's a dash one here. We'll do dash. I'll just make it very obvious. We'll do like a red dash. So, okay. So there you go. Now on a floor plan, you can see that this is below underground. It's under your level. It doesn't have to be on grade. Obviously, if you did the second floor and you want to show something on the first floor, you can show it like this too. So play around with this setting and then make sure that your line style is something that you want to make it differentiated from underground versus above ground. All right, so there's that one. I need to drink water. Underground. Adding projects to. I need a moderator. Keep track of these questions. Trouble scaling when it comes to adding projects to printing templates. Scaling. Kinu. Might need a little more background on that. Scaling when it comes to adding projects to print templates. Print templates. Like, are your drawings not coming out the right drawing size? Like, this should be set up for probably 30 by 45. Oh, it's asymmetric. So it should be coming out like this. If you're not getting the right print size, like if it's coming out 8.5 by 11, it could actually be your print driver, not Revit itself. So like in here, you have to make sure that your paper match paper source. Oh yeah, see, so this one automatically matches, but sometimes your paper source might not be the right scale. It'll just print on like 11 by 17 or 8.5 by 11, even though your drawing is set to 30 by 42, and then your scale is going to be all off. So yeah, you are right about that. So make sure this paper size matches what you need to print. Is 30 by 40 even on? Oh, I'm sorry. I'm terrible with this. So over here, properties, make sure that your paper size is automatically selected. And then over here in setup, make sure that your size of paper matches your drawing size. If you leave this at letter size and you try to print a 30 by 42 on it, I mean, it'll PDF, but then, you know, all your scales are messed up because it's not 1-to-1. And the other thing is, I hate to zoom this thing. So what is A0? Do I even have that? I'm not familiar with this size. Let's just put it on here. It should be, yeah, okay, so zoom is always 100% to size. Like, you don't want to fit to page because then it starts messing with your ratio and your scale. So I do zoom 100% and either one works. I think center probably looks better in case it's slightly off. So you would set up like this, hide unreference. These four should always be checked. And then once you plot it like that, it should come out half decent. Nope, this is all screwed up. So this drawing's not right because I don't know what the I don't know what this drawing scale is. It's metric. I need my my horrible imperial project set up. So I'll try to do better next time. Hopefully that answers that question. Oh, let me see what some of these answers are. Yeah, Kinu, let me know if that answers your question. You have to make sure your drawing page is set up to match your title block, and then that your PDFing software also uses the same. It all has to be the exact same so that whatever scale you have shown on your drawing, it should be scalable. Like quarter scale should be actually quarter scale once you print it out. And it also should be quarter scale in PDF. If you have a PDF tool that measures stuff for you, you should be able to set it at quarter scale and it should measure exactly. So that might actually be a really, really good video topic actually, talking about drawing scales and how to produce a scaled drawing set. So, you know what? I'm going to write that out. Somehow. Make drawing scale. All right. How to panel schedule different load count per NEC demand. Ooh, that's a good one. So, yeah, you can actually make panel schedules work for you. So let's go over here. So we'll talk about this real quick. I think what you mean is load classification. Oh, do they have none of this set up? Oh, of course not. Okay, MEP setting, electrical settings. There should be load classifications. Here it is. Load classification. Yeah, all of this should be selected. HVAC demand factor. You see where I'm diving in? There's like several layers to get in here. And you can do by quantity. Here it is. So this is per NEC. So for example, if you have like a multi-motor array, I think you're supposed to take, was it 125% of the largest motor and the 100% of subsequent loaders as your demand load or something like that. And there's a lot of them, like lighting, I believe should be counted. Yep, lighting should be counted at 1.25. Receptacle is a special one where you have to do the first 10,000 and 100. Yeah. So this is where you set this up. So it's under demand factor. I think you can actually get here directly. Let me go to manage MEP demand factor. Here it is. So you go here to demand factor. You can set up everything per your local jurisdiction's code. Let's say, for example, motors. Here it is. See? Incrementally for each one. Okay, yeah, 125 of the first one, and then all subsequent are 100%. So you set up your demand factor here. And then when you start putting your equipment on the floor plan, let's go here to here. Can I put in like a motor or something? Oh, I don't want you. Go away. So let's see. Go to systems. Electrical fixture. Please tell me you have a motor loaded in here. Gosh darn it. Okay, I might be able to use this. Electrical fixtures. Okay, so just for giggles, when you select a piece of equipment and you power it up, you actually have the ability to adjust the load type. Come on. Click on the fixture. There should be a load type. Maybe receptacle is not one of those. Edit type. Yeah, probably a bad example, actually. Receptacle's pretty locked in. You have to pick something that is outside. Like, I want a motor. Can you give me a motor? I would love to illustrate this point. Let me find a motor. Let's see, Revit, families, electrical equipment? Sure. Pull box, floor mounted, transfer switch, clearance, control panel. Huh, there's a VFD. Maybe a VFD might work. Let's see. Where'd it go? I lost it. Hello? Why are you on the ground? Sheesh. Yeah, I didn't host that right. Let's pick a new host. On a face. E. Come on. Ooh, this is struggling. Let me make sure I have this. Yeah, make sure I'm showing you guys this right thing. Okay, so put it on the wall. Put it on the wall. On the wall. Perfect. All right. I like how it doesn't show up on here. Level 3. Ooh. Let's make sure that it's. That's probably why. Actually, let's make this like 5 feet. Where are you? Okay. Okay. All right, there we go. I finally have my VFD. So, all right, let's grab this because this one actually has a load classification that you can change. So over here, you can pick all your classifications, and when you classify this, this helps with your demand factor. So you make sure that this is under motor. On HVAC to take motor. So hit OK, and there we go. And then when you power this up, I don't know, usually it's 480. When you power this up, you go to, oh, it's going to LP1. Sure. I would never put it on lighting panel 1, but for giggles, let's do that. So yeah, here's your HVAC load, and you can see that load classification is down here. I don't have a load on here. Let's grab that. Come on, let's grab that here. 1500, sure. And there's your load, and it throws it down here as HVAC. So this counts it as the first motor, so that's why it's something that's ridiculously large. And then if you have subsequent ones, so count another and another. Let's circuit all of this up too. Come on, there we go. And then you come in here, here's another one. So you can see that it's starting to do the math for you. It's taking the first one at 120% and then the subsequent ones at 100%, and you'll start seeing this demand factor be applied. Then you'll have your estimated demand, and then that trickles down into your panel schedules math. So that's where you find everything. Under MEP settings, do your demand factor, and then make sure your load classification has the right demand factors linked up. So like you saw what I just changed here, like HVAC, I want to use motor. Lighting, I have to make sure the demand factors for lighting. Oh, actually, there was a motor category. Okay, so you could use motor. Maybe, set that right. Have your classification linked up to the right demand factor, and then when you're placing your equipment and powering it up, put the right classification on the side here. Load classification under electrical loads. Make sure that's select to the appropriate one. Okay, so that's that one. Let's see. Scroll through. Can we add in panel schedules fault current and voltage drop in Revit automatically? Panel schedules fault current and voltage drop. Honestly, I don't know. I don't think we can actually do voltage drop automatically. I've always done that manually. Add in panel schedule fault current. So we do fault current, at least for our company. Where is it? AIC. I mean, you have AIC, but that's nothing that's calculated. I'm pretty sure. Yeah, the AIC value in here is just something that you type in. So I don't know, 22,000, amps or something like that. But it's not calculated in Revit. I'm trying to think. Can you do voltage drop? I don't think you can do voltage drop on here. I know Revit will try to make sure that you're not exceeding 80% of your breaker. So it knows that, but I'm sure it doesn't do voltage drop because it doesn't actually know the routing path. Because I know, like my last project, we had to do it manually because it's not just from point A to point B in a straight line. So to account for voltage drop, you have to account for the whole run. So it doesn't know if you're going up a chase. It doesn't know that you have to follow a corridor. So I'll have to look into that, but I want to say the answer is no. You can't add it in automatically. There's no fault current or voltage drop calculation natively in Revit that does it automatically. There might be a plugin for that. Because I know there is this one software that you can do basically an electrical design and it generates a single line for you. If it does that, I'd imagine you could do AIC and fault current and all that stuff, and voltage drop. But you'll have to put in like conductor length and distance and everything like that. So like you start from your source, I don't know, 65,000, and then it'll have to know all the distances to the panel. So at the moment, no, I don't think you can do that, but would be interesting to find out. Let's see. How to export IFC files show geometry problems. Oh, okay. I think I know what you're talking about for like Navisworks and clash detection. Ooh, I don't export too often, but you actually, if I remember correctly, you have to make a 3D view. It was like BIM 360 Clash. Oh, right. Okay. So our BIM department mostly does that. And they actually pull an IFC file from each model independently. So what I mean is like in this, for electrical, they shut off everything except for electrical equipment. So they would turn off like the walls and the mechanical stuff, and then it would just be like a bare 3D view of nothing. And then you go to like electrical equipment fixtures and maybe like lighting fixtures or something. So they would make a view that, yeah, that kind of looks like this. It'll just be a floating stuff in here. And then they would take this, they would export this, and if I remember correctly, here it is, IFC file. So they use this, or there was another file format that I believe was used. No, maybe it was just this. It's been a while since I've done that one. But I know you have to like make a 3D view and you export that, and then it becomes like a Navisworks file that you link in. Then you could do a clash detection in Navisworks. We've been actually moving away from this, believe it or not. We actually don't use Navisworks anymore. We actually use BIM 360's Clash Coordination, which is like hosted on the web server, like BIM 360 web server. So our BIM department takes care of all that for me. So I've just been very much out of touch for that. But it's really nice because like it runs much better than Navisworks did. Some of the features like you can measure easier, you can annotate better. What else was the other one? Oh, you can mark clashes and you can assign them, and someone will just get a notification for that. So it's nicer in that regards. It runs off of the iPad nicely too. Like I can actually show clashes on a mobile device. So we've been moving towards that, and we've been kind of ditching Navisworks. So I haven't really made an IFC file in a while. So, okay. Anyways, that's as much as I can offer there. Sorry. Let's see. What time is it? Holy moly. More than a half hour that I was planning to do. Can we add in panel sketch? Can you work in an existing project that use panel schedules, Excel or Revit panel schedule? When you work in an existing panel, or when you work in an existing project that should use panel schedules, should you use Excel or Revit panel schedules? I'm guessing your question is, for an existing project, should I make Excel panel schedules or Revit panel schedules? I've always done Revit just because like, well, actually, no, not true. I've done Excel recently too. So it kind of depends on the project. If you plan on adding loads to existing panels, then yes, I would do it in Revit. So I would make a panel, make a schedule for that, fill it out with spares, and then I would just rename the spares as an existing load, make sure they're not bolded, and then the new loads that go in there, I would make sure that those loads are bolded, and then have a note at the bottom of the panel schedule that says existing loads, or new loads are shown in bolds. Existing loads are shown for information only and do not have loads provided. So something, I guess I could pull this up again. It'll look like this. So like I would fill this out with some spares. Actually, I will lock it too. Yeah. So existing, or I think it's EX that we do, hot water heater, and then I think actually, can you do this? I think somebody told me that you can actually put loads in there now. Ooh, that was way more than I wanted to. It's supposed to be VA. 100 VA. Will that hold? Oh, you actually can now. Okay, so fun fact, I just figured this out. You can actually add load to a spare breaker now. I guess they figured out that we tend to use this for existing load. But if you know the load for an existing load, put that in. I generally don't. I generally leave this all as 0. And then when you have, come on, 0. There we go. So I would put an existing load like this, leave the load at 0, and then just put in the loads for the new loads. And I believe you could do edit font. Here it is. So I would do bold. So there it is. Like the new loads would be in bold, and then the existing load would stay in this light color. And then under here, I would tell the contractor that new loads are in bold, existing loads are provided for information, or existing circuits are provided for information only. The load shown on the panel schedule is only for the new loads. So I just want to make sure that that's very clear for them. I generally try not to take responsibility for existing loads that we're not touching, because you honestly don't know what the specs are for this water heater. Like, do you know it's a 20? Or, well, okay, so maybe it's a 20 amp, but do you know how much the load is? You have no clue. So I try not to do that. I've been doing it, like I said, in Revit if I need to connect new loads to this. If it's all just existing panel schedules that we really don't need to do any work in, I actually have done it in Excel, and then we just PDF that thing, and then we take the PDF and we stick it on the drawing. That way, we don't have to mess with it. It's just faster sometimes to create it in Excel, so I understand the desire to do that. But if you need to connect something, yeah, I would make the panel, I would mark it as existing, and I would build the panel schedule in Revit. All right. What's the setting you showed? Ooh, I probably blew right past that. Slice fines. Sorry, I don't know which question you were referring to. I don't know what setting that is. I completely missed that. I'm sorry. All right, what's the last one? Yeah, I should really start wrapping this up. Almost done with my lunch. How to add a pilot light indicator for my high-rise building. Pilot light indicator. Pilot light indicator. Okay. Vishnu, let me answer your question first, and I'll come back to the pilot light. Wouldn't that make the panel schedule incorrect? Yes, absolutely. That would be unless you know what the existing panel loads are, how would you ever know what your new loads are? So that's always a tricky bit with using existing facilities. You can meter it. That's actually the best thing, is to have someone meter it for a couple days, and then you'll have your existing load. But then you don't know exactly what breaker is feeding what. So my approach has always been, if you don't know the loads and you don't know the transformer size, it's really, you can toss that back on the EC, which is terrible to do, but what else can you do? You take the new loads and you be like, okay, this is your new load, this is your new amperage, and you guys got to figure out what your existing load is to make sure your transformer is not oversized. I know it's a dicey game. That's why generally I try to just put my own distribution in if I have a sufficient load to justify it. The other approach is that most of your panels generally don't see more than, I'd say, about 50-60% of connected load. So if you know the connected load, you could take half of that and then try to just I would try to like put it here as like existing load, existing 3-phase load, drop it at the bottom, do your math, and then remove that. Like, I try not to put existing loads somewhere on the schedule. So if you want to make sure that you're not overloaded, so like if you know this was a, I don't know, we'll say 45 kV transformer, and you just want to account for half of that, we'll say 21 divided 3 ways, so that's what, 7,000 each. So you do like 7,000, 7,000, and then, oh, well, that's kind of annoying because then your demand current. It's a good question. What's the demand rating on this? Honestly, because I don't want to take demand twice. so if I do 100 and I see, watch this number over here. Oh, it's just, okay, it's 100%. All right, so add another 1,000. I see this jump up. Yeah, so connected and demand jumps up at the same rate. So this is demand factor of 1. So yeah, I would do it this way. Maybe put like 7,000, 7,000, 7,000, and then just use this to kind of double check yourself. Okay, so that's, you could say like, pretend the top doesn't exist. You put that in, you're saying this is your total connected current, make sure your panel's not overloaded, and you have your estimated demand. So you can start with that, do it this way, and then add loads as you see fit. Then after you're all finished, you can just double check to make sure your demand doesn't exceed your transformer and your amperage doesn't exceed your panel. But like I said, at the end, I would personally pull these back out because you honestly don't know what the true load is if you're working on someone else's work. Yeah, so that's kind of my solution for that. I don't do too much with existing work, so most of the time I tend to add my own stuff. Every now and then, if I do add existing loads to existing panels, it's only a couple circuits. It's not that much, but that could be an approach. Let me know how you think of that. All right, I am closing in on 1 o'clock, so I think I'm gonna wrap this up. Yeah, obviously this didn't quite go as I planned. I was hoping to have Tom in here. We'll try to shoot for maybe Friday and see if we can get the audio working. Ideally would be like a 2-person conversation. We'll have a couple topics and then we'll talk about it. And if you guys come in with questions, then Tom and I could try to answer them. Plus, I just need someone else looking at the chat because like as I'm reading this, I'm obviously not doing my explaining or anything. So thanks for attending. I love that you guys are here. I really appreciate your support on the channel. It means a lot because I do this just because I want to. Like, no one pays me for it. Honestly, YouTube doesn't even pay me for this. This is completely not even monetized yet. But I do it because like I've always had problems with getting information while I'm working. I used to be in a smaller company that like our senior engineer guy was hardly ever available, and I'm always like, how do I do this, or you know, what's the design philosophy of this, and I could never get the answer I want. So hopefully this channel grows to be a useful resource for anyone in the electrical department, designer, engineer, what have you. So as I grow in my career, I want to just have more talking points, talk about, you know, some pitfalls, all kinds of stuff, how to manage a project at one point. I do want to touch on that because I know people that are just graduating from college, they're getting into the field and they're just completely overwhelmed with how to start a project from, you know, start to finish. Like going from projecting your man hours and your expected deliverables to like wrapping it up, sending it to construction, and then handling the construction administration part afterwards. So end to end, there's so much in between. And yeah, I just hope that at one point this becomes a very useful channel for anyone. I appreciate all your questions. I love your support on here, and hopefully I'll see you guys in the next one. All right, so thanks for joining me and have a good day. Bye.